Some nights I stay up working on my pre-calc until I can't figure out what I'm doing. Some nights I stay up, I want to go and cry myself to sleep, 'cause I don't know. But I still wake up, I still see Klein's face, and then I know he's going to teach us the stuff. Those nights I don't know. Any pre-calc, any pre-calc. Wow, what a great intro. What a great intro. I hope that doesn't happen to you guys. You stay up too late doing your homework. If you do, fantastic. Anyway, here in 4.4, this is going to be somewhat similar to 4.2, where we're going to be evaluating trig functions, so you're going to need to know your unit circle. We're also going to find reference angles. This is going to be kind of new. And then we're going to evaluate trig functions of real numbers. Basically the same thing as the first bullet. So, if you have a point or any angle on your circle, and this doesn't have to be on your unit circle, but what if this would make a big circle here, the distance from your origin out to this point is your r. Okay, so it's like your radius of your circle. I think that's why they call it r. Yeah, that makes sense. In order to find your sine of theta, no longer is it just y, but it's going to be y over your r. So if you made a triangle over here at this point and your horizontal axis, then to find your sine value, if this is your y and this is your x, and this value is your r, you would say my sine of theta is equal to my y divided by my r. Similarly, the cosine is your x over your r. Your tangent is still y over x. Your cotangent is still x over y. But then your secant is still just a reciprocal of your cosine, and cosecant is reciprocal of your sine. So if we look at example 1 here, we need to find our sine, cosine, and our tangent. So we have this pretty little excuse me, triangle here. And if we draw this down, and that's a nice straight line. If we draw this down, and there's what I wanted. If we draw this down to the 3, and then we want to draw our little our little box here shows a right angle. This distance is -3 here. This is a +4. Now we don't know what r is. So in order to figure out what r is, we need to do a little something called the Pythagorean theorem. So r squared is just going to be equal to your x squared plus your y squared, or the same thing as a squared plus b squared equals c squared. So r squared is equal to your x, which is -3 squared plus 4 squared. So r squared is a 9 plus 16, which would give us a 25, and r is going to be equal to 5. It's not plus or minus 5, because whenever you're talking about your radius of a circle or your r distance, that is always positive. Okay, the only thing that can be negative would be your x's or your y's. So your r is always positive. This is also a special right triangle that we will use a ton, metric ton here. This is your 3, 4, 5 right triangle. It's a Pythagorean triple. So anytime you see a triangle with either a hypotenuse of 5 and a side of 3, or a hypotenuse of 5, side of 4, or if you have a 3 and a 4 here, your other side's going to be of this form, 3, 4, 5. Alright, so keep that in mind. Now, all we have to do is, now we have the 3 sides of a triangle, is just go through and find our sine of theta. Remember, that is now our y over our r. So our sine of theta is a 4/5. Cosine of theta is your x over your r. So this is a -3/4. Sorry, 3/5. -3/5. And your tangent is your y over your x. So 4 over 3. So there are your 3 trig functions.